What's up, everyone? This is part B. We did the first part of the proof for page 428, and we got through 7 steps of it, but there's still 5 more to go. And so that's what I want to do in this part B, is wrap up this proof that shows us that this line segment DE, zoom in for you, this line segment DE is the same length as this line segment EA. We're going to use corresponding parts of congruent triangles to do that. And then we're also going to prove in this step that ID, the arc from I to D, is the same as the arc from I to A. Now, in order to set that up, we're going to be using something that we've been working on through this entire module. And it's that this angle right here, this angle DOE, angle DO, is going to create an intercepted arc that's a central angle and an intercepted arc, so therefore they're the same distance or the same measurement, amount of degrees. And then this angle, angle AOE, area of effect, area of effect. So angle AOE is also going to create a central angle, IA, and those two are equal. Well, because these triangles are the same, then by corresponding parts of congruent triangles, these two angles are the same, which means that these intercepted arcs created by those angles are the same, throwing a lot of congruence all over the place. That's really where we're headed. So let's see where we were last left off. All right, we have a statement of reasons and statements of reasons that lead towards pushing that we have actually identified congruent triangles. Those triangles that I mentioned up here, the triangles here, DOE and AOE, those two triangles are the same. And from that, what we now need to be able to do is say what I just said. That is two things. And I'm actually going to need more paper, so I'm going to scroll a little bit more here. Okay. By what we say, the corresponding parts of congruent triangles. There's my left side, right side. That looks kind of vertical. Here we go. The corresponding parts, by corresponding parts of congruent triangles. Then this is statement 8. We're going to say angle DOE is congruent to angle AOE by corresponding parts of congruent triangles. And line segment DE, which is what we're trying to prove, is congruent to line segment AE. Now, this statement right here answers one of the things from our conjecture, that when you have a chord on a circle and you draw the perpendicular bisector to that chord, it's going to cut the chord in half. It's going to go through the center of the circle. And it's also going to bisect the intercepted arc created by that chord. A lot of high-level math words there, I realize. I feel big brain in this moment. Are you big brain too right now? Okay, so then we have the reason for those two statements being true. They're matching parts or corresponding parts, and they're on congruent triangles. Triangles that are the same size. So if matching parts from one triangle and the other one, like if the triangles are the same, then the parts are the same. So corresponding parts of congruent triangles tell us that they are actually congruent. Like that's what we're looking for here. And it happens in 2 different steps: the angles that are created and the segments that are created. All right, so then let's take that into our meaning. Draw a line right here. We're on step number 9. Don't need you. Don't need you. There we go. Step number 9. Since DE and AE are equal, that was one of the things we had to prove. We had to show that the diameter bisects the chord. And so this one, check. That's done at step 9. And then the diameter bisects the arc determined by the chord. So we have to get to that point right here. So that's what my step 9 is going to be. My step 9 is going to be that if angle DOE is the same as angle AOE, then that means that arc D, I need to get the arc measurement. Where we at? Look at the thing up here, DI. Okay, DI is the intercepted arc created by angle DOE. And AI is the intercepted arc created by angle AOE. Okay, this is my statement. MI bisects DA and MI bisects arc DA. Okay, that's what I'm missing here. All right, so I'm going to make that be my statement 9. I know I wrote that thing. I don't really need to write that thing anymore. So here goes. Let's erase this. And let's go M. Oh my gosh. You see that too, right? Okay. There we go. MI bisects DA. And the reason is congruent segments DE and AE. The only way that that could really happen is if they're actually parts of the same line that's being bisected. Okay, definition of bisect. Now, next up, this is where statement 10 steps in. Statement 10 is trying to prove that other part that I'm still waiting on. So, sorry, stick with me. You're doing a great job. Here we go. See, can I make this one a little bit longer? Yeah, there we go. Okay. 10. Statement 10 is to say that the arc created by DOE. That means that that's arc DI is congruent to arc AI. Now the reason that that's true is by the definition of central angles. We have central angles that create intercepted arcs. Those central angles create intercepted arcs, and the central angles are congruent to each other. We call them inscribed arcs. So once I can say that one arc, that's DI, is the same as the other arc, like continuing on the same circle, AI, if those two arcs are the same, then the final statement of our theorem, sorry, the line is all wonky. The final statement of our theorem, statement 11, says MI bisects arc DA. Put a rainbow up there for arc. That's the final statement. That's the last part of the proof that we need. And the reason for that, again, using my resources, literally it's just the definition of bisect. Hey, kudos to you. Doing proofs like this is tough. It's not easy. And yet here you are watching this video all the way to this point, trying to make sure that you have a complete answer for what is the proof of the diameter chord theorem. A diameter chord, like that line that goes through the middle of the circle, a diameter chord is perpendicular to any other chord created along, well, wait. If the circle's diameter is perpendicular to a chord, then that diameter bisects the chord and also bisects the arc determined by that chord. This is the proof for the picture right here. Thank you for watching this video. We have page 429 next on deck, and we're gonna continue our journey towards fully concluding all of this module on the proofs and properties of geometry. So thank you for watching. See you in the next video. You are awesome. Bye.